you're going to be looking at creating scatter plots and figuring out lines of best fit. But before you get to that, there are just a couple of definitions and terms we need to go through, which we've already seen the correlation coefficient, but now we're going to really look at it in a mathematical way and not just as like a feeling based thing that you look at the scatter plot and you think it's moderate or you think it's strong. We're going to actually analyze it precisely. So, yeah, just reminding ourselves of correlations. When we were looking at correlations, we were saying, like, how strong is this trend? If you were to draw a line of best fit, does that line of best fit model that data really well? In this case, that's doing a pretty good job. Whereas if you take a look at this next one, kind of like has that trend, but it's not that great. So maybe you'd say moderate. So that's what we're initially looking at when we were looking at the strength of a correlation. So the first one's stronger, second one's moderate. We also mentioned, like, is it linear or nonlinear? So that was a big component. Both of these are linear. They look like they're, in general, have that trend along some kind of line. It doesn't have to be perfect, but there is that trend. And there is also whether it was positive or negative. So that just means as you go from left to right, is it increasing or decreasing? So here, that one's positive, and that one's positive as well. All right, continuing on. So what we're going to look at today is, what if you actually had a number for the correlation? And there is a way to get that number. There are a set of formulas that you can use to calculate a value for the correlation given any scatter plot. We're not going to get into the actual formula. That's part of the grade 12 data management course. So wait a few years and you can then have some fun with that formula. For now, we're just going to let technology do the work for us. So what we call this special numerical value is, it's actually the Pearson correlation coefficient. Pearson's just the dude who found out or came up with this value. And more often, we often just refer to it as the R value. So what it tells us is, when you have that number, it tells us what is the direction, because that number is going to be either positive or negative. That's why we've been describing those correlations as those words, which would be, again, increasing or decreasing. And the other thing is the strength. So is it strong, moderate, or weak? So let's take a look. So here are some actual example correlation coefficients. So what you'll see is we have this correlation. It's a perfect line. That actually has an R value of 1. And then as you can see, as we go from left to right here, pretty good trend. R value 0.95. And not as much of a trend, 0.66. For all the ones on the bottom, you can see they're all negative values. They're all going down as you go from left to right. And then you can see -1, again, is perfect. And the closer you are to that -1 value, so -0.97 is really close to -1, the stronger the correlation. And this one, which is closer to 0, not as strong of a correlation. So let's actually precisely define what this all means. So in your note, you can get these parts down. The correlation coefficient is always a value between -1 and 1. And what's important is the sign of it, that, as we saw, tells us what the direction or what kind of correlation is. So positive value is just a positive correlation. Negative value is just a negative correlation. Then we also have the actual value of the number. So what I'm going to say is we're going to look at the magnitude. So what I mean is just looking at the number without the sign. So if I were looking at like -0.97, let's just think about it without the sign. The sign's telling us the direction, but 0.97. 0.97 is very close to 1. And so the closer your value is to 1, or you could still think of it as closer to -1, then that tells you that you have a very strong correlation. However, as you get further and further away from 1, or -1, so closer to 0, then that tells you you have a weaker correlation. Okay. And we can even make this a little more precise. So when we were going through our previous scatter plots, we had said, oh, this is strong, this is moderate, this is weak. How can we do that with these numbers? Well, all we need to do is, since we're looking at a range from -1 to 1, that's where our correlation coefficient can be. We'll split it up into either negative correlations or positive correlations. So that's what this graph, or this little chart, whatever you want to call it, is doing. We're just going to split things up into 2. And then, on both sides, split those into thirds. So like, what's a third of 1? So 1/3, you can think of that as 0.33. 2/3, you do the calculation on your calculator, 0.67. And those become the boundaries for what defines weak, what defines moderate, what defines strong. So if I'm very close to 0, that's weak. If I'm kind of in the middle of 0.33 and 0.66 or 67, that would be moderate. And then if I'm really close to 1, that's strong. If you're exactly 1, that's when you get the perfect positive correlation. Same thing on the left side. So splitting it up into thirds, you could have -1/3, which is -0.33, -2/3, which is -0.67. And again, what's closer to 0 is weak. And as you move further outwards from that, towards the -1, you're getting stronger and stronger. So there we have it. That's what our correlations look like. So now, whenever you have a scatter plot, if you're able to find the value of the R value, as in the correlation coefficient, then you can precisely say exactly how strong and what direction that correlation is going in. Okay, so taking a look at these examples, R equal to 0.26. So let me just go back up. Let's have that actually at the top of the screen. So you can see 0.26, let's put it's kind of like a number line up here. 0.26 would fall somewhere there. So it's lower than 1/3 and higher than 0. So what we can say is first of all, it's positive. And it's a weak correlation. For all of these, we're just going to assume they're all linear. And for the second one, R equals -0.74. So go to this number line. -0.74 is to the left of -0.67. So it's close to -1. And so because of that, we can say that, well, first of all, it's a negative value, so it's a negative correlation. And it's strong because it's close to -1. So a negative strong, or a strong negative correlation. Okay, so that's a look at using the R value, how we can get our strength and direction of the correlation. All right. The thing is, we were only looking at lines there, but not everything is a line. We've seen occasionally some cases where maybe something like a curve. Look at that. That curve seems to model that data pretty well. Same thing to the right here. This curve, that seems to model the data pretty well. Whereas if you're to draw a line, the line, not that great. And over here, a line, I don't even know how you draw a line for that. So curves can be better in certain instances. So we want to figure out how can we say how good that curve fits the data. So we're going to do that, but we're going to do it just in a slightly different way from what we did with the linear correlations up above. So that's just what I said. We have curves of best fit. They are lovely. So for a curve, we have a different value. It looks very similar. Instead of the R value, it's now just the R squared value. So like with the line, we can ask ourselves, how well does our model fit the curve? and this number is going to tell us. So it's a little less specific than the correlation coefficient because it doesn't mention anything about direction, because curves aren't necessarily always going in one direction. All it says is how well does it fit. That's it. And so because of that, it's only going to be a value between 0 and 1. And if it's closer to 0, like the correlation coefficient, it's a bad fit. If it's closer to 1, it's a good fit. And we're not necessarily going to subdivide it like we did with the correlation coefficient, the R value, into all those different sections. This is all we need to know. So with that, now if you're to make a scatter plot, if you're to make a line of best fit or a curve of best fit, you can know precisely, if you determine these values, how well that line or that curve fits your data. All right, that's everything. And now you can move on to the investigation.